Alright, another draft physics video with a quid pro quo. So now he's supposed to be getting on the subject of my query about gravitational lensing and one of its consequences, which sort of, in a sense, creates big problems for it as a theory, in the sense that we see a tiny portion of the universe at the focus that allows a gravitational lens to allow us to see something that we wouldn't be able to see without the lens. And the consequence is that we're not going to see hundreds of times more things than the thing we're going to see. So for everything we're seeing because of the lens, we won't be able to see in its rightful position, or we won't see at all because of the gravitational lens. So the lens will annihilate more stuff in the universe than it will make visible in the universe by theory. And the problem is because of the nature of the gravitational lens. It's a very unusual lens. Essentially, the inverse square law creates a really crappy visual lens. It might as well be you're looking through a crystal ball or something, and it's going to make things over here appear like they're over here. It's going to really mess up the universe. And yes, a few things that might be obscured by something else it will make visible, but very few for all the things it annihilates. And like I said, every view, if we just do it for temporary purposes, every view through the lens this way, at this angle, can't have any hope of seeing anything here in its proper position. There's no hope at all. Anything, any light coming this way, it just has no hope of seeing any of it. And there's lots of lenses in space at all kinds of angles. And so we should see huge amounts of distortion. We should see double images all over the place, because those are going to be created also. So there's two ways you can see something. So here's a something. You can see it by the light going straight, and you can see it by the light going this way. So there's two views you can get of everything, and all of that gets screwed up also. So anyway, so I made that argument. Nowhere in this does he explain how that's incorrect. So just giving you a fair warning. This isn't going to be. He doesn't have a counter explanation to the point that more stuff is disappearing or being distorted than stuff being made visible.
Back to the answer. It's all to do with the fact that the universe is very sparse.
Yes, that's another point I was making about why lensing can't happen in the places you're saying it happens in, is because that sparseness means the gravity from each one of these objects. If I was to place something here and say this is a lens of some kind, it's a gazillion trillion times too weak to lens light from this star, and it's a zillion times too weak from this star, and a zillion 1.5 zillion too weak from this star, a zillion 0.3 too weak from this star. So even if you add all those stars up and you had a billion of those stars, you're still a zillion times too weak. You can't create a lens out of air. You have to create it out of substance, matter. And again, the best lens is like a sun. If you can make the sun twice as big, you might have a really good gravitational lens, because then you could get up to 200 or 300 meters per second gravity over a very long, wide area. But these lenses have no hope.
Yeah, there is way, way, way more empty space than...
Right, so you're making my point. The lens is made out of empty space, which is theoretically mushy.
Stuff. Galaxies can collide, and often do, and it's expected that there are mostly no collisions between stars when galaxies collide.
Well, I'd say that sounds a little bogus to me. I think it depends on how they collide, right? This way to this way, or on edge on edge. If they collide on edge, there's going to be some suns hitting some suns.
So even the dense parts of space are not dense. Okay. Now then,
Exactly my point. Even the galaxy is full of empty space, as you're just illustrating. And so again, this argument that you can cut the gravity by, make the gravity a billion, a trillion times weaker, and just claim that I'm in it longer. Well, it doesn't matter. You're not in it long enough, okay, to make it work. Still doesn't work.
for an object to appear as an image, what you have to have is a coincidence, kind of. You have to have the observer and the object in some kind of focal point arrangement.
Right, and let's understand that when you look at something regular in space, you don't have to worry about this focal point crap. You can just look at it and you can focus. You can create the lens right in front of your eye and create the telescope or whatever, and you can create the focus. So you're in complete control of the focus when you're looking at something regular. But it doesn't change the fact that the light from this thing got completely messed up when it went through this gravity. And now you're not going to be able to see this, because this light from this object didn't go here. It didn't go in straight lines. It got bent, and it's gone. This object disappeared. So you have your little bit that you gained. You got to see this star where you couldn't see it behind this one, but you lost everything else in the picture. Got screwed up. It's either gone, you can't see it from where you are, or you're seeing stuff you shouldn't even be able to see because it's way the hell over here. And there's no evidence the universe is doing that.
So it's probably true that there are places you could design you could pick your observer position and you would see half a galaxy, as you put it. But I would say, in fact, that's kind of what we're seeing, when we see half arcs. Yeah.
No, those are the lensed images. You're not seeing half a galaxy. Let's say, let me see how to put it. Where half of it's lensed and half of it's not. You're not seeing galaxies in the periphery of lensing where half of it's lensed out of your view. So half of it's sticking in this lens and half of it's not in the lens. And you should see that. You're not seeing that. You're seeing things in the lens or not in the lens. But you don't have any images of things going through the lens, going in and out of the lens.
We're seeing distorted images all the time because of the difficulty in getting the perfection of the lens, so to speak.
The only ones you're calling distorted images, again, are when you have this perfect focal length nonsense. The distortion's happening with every focal length from this perspective. Every focal length from this perspective, the lens wipes it out. You can't see anything. Anything in the universe from here to here. No, anything in the universe from here to the dimension of the lens, so let's say here, is gone. You're not going to see it the way it is, and you're not going to see it the way it is. Because it's not even it's not an optical lens. You're seeing it through the inverse square law. It's not a optically useful lens.
Oh, the fact that the lens is not merely an optical lens of a sort at all, and is very much distorted.
Yeah, distorted by symmetry. Let's understand, though, it is a symmetrical lens because gravity is round. In spite of what your nonsense proclamation that it doesn't have to be, is fundamentally, in most cases, it's got to be. Strong gravity is going to be round because the material objects can't be in strong gravity without being forced into some sort of spherical shape.
Lens type thing, giving one aspect of a lens type phenomenon. As for Jupiter.
So, now the Jupiter thing. Well, anyway, I'll let them say it, but I mean, you're not going to go into enough detail that matters. Okay? Jupiter's gravity is 2.5 times that of the Earth's gravity. So we're talking about 25 meters per second, which, as I pointed out, is a little bit more gravity than one radius from the Sun. And the advantage for Jupiter is that it's 3 times further away from the Earth than the Sun. So that means you have the advantage of your smaller angle. The
reason of sparseness applies. For one, because you've just picked an object. Yeah, you've arbitrarily picked your object, picked your observer position, Earth.
And again, and that's exactly the way they illustrate. So why don't you just go to the Gravitational Lensing page, Wikipedia page, and I'm sure they have the little simulation on there with a black hole swirling everything around it. You can't miss it. You can't miss that everything's getting fucked up. Not just special things, every single thing. Every photon that goes near the black hole gets fucked up.
And said, why don't I see no images?
Look, the Eddington experiment, when they do that, the photo plates on a clear day, they would expect to see 10,000 objects on their plate. 10,000 suns. Now, they end up doing the experiment with only 1,000, so they were way below their clear weather expectation. And they're just picking. They're picking a good candidate out of those 10,000. Well, obviously it has to be one close, and it has to be one far. Close to the sun, and the further in distance, the better.
And as I tried to explain, it's not, you can't do that. Yeah? The arrangements happen where the arrangements happen. They're probably...
That's just not true. The photons are bent, period. They're all bent. Doesn't matter how far away it is, they're bent. So the object either disappears, or you see it because of the lensing. But those are the only two options. There's not some third option. You either see it in the right place, you see it in the wrong place, or you don't see it at all.
Are positions, perhaps, of which you could detect the bending of light around Jupiter. But that would be also a prerequisite on it being a particular kind of object that you see. Because Jupiter...
No, it wouldn't be any particular kind of object, any of that crap. It just has to be something that's not Jupiter, that's next to Jupiter. And then you can see how it moves because it's moving through a lens.
So it's still a very tiny mass, and that the disk, it may well have trouble because of its atmosphere, that where the gravity just about is good enough to produce within our solar system an image on...
Look, my argument is that it's close. That's all I'm arguing. I'm saying you keep... I'm just hearing all these whines about why they can't point telescopes anywhere near the sun. All right, that I claim are just whines. Like I said, they could put one in the space shuttle. They could have put one in the space shuttle. They can put one on the space station. I'm pretty damn sure it has a decent telescope on it. If it doesn't, then NASA's pretty retarded. So what's the big deal? They could have done the experiment in perfect conditions in space on the sun, and they haven't because they're scared of the sun. So I'm just trying to come up with some alternative that you don't have to be afraid of.
Aye. It may be that because of the inverse square law, that in actual fact it would never happen because there would be what you call diffusion, I think. You have a diffuser on a fluorescent light.
So again, yeah, and the sun's corona isn't a diffuser. So I just say double standard all over the place. Oh no, the sun's corona is no problem, optically pure, not diffusing light at all. Well, but Jupiter's atmosphere is. Bullshit, I'd say to that crap.
Light to scatter the light, randomize the light. So the process is diffusion when it gets too close to a body with an atmosphere.
Yes, well, I'm saying at the point of its atmosphere is pretty clear. It has a pretty hard line. Its atmosphere is, and then it stops. It's not flowing or moving or doing any of that crap. So at least it's got an atmosphere that's kind of stable. So I'm just saying go to the edge of the atmosphere and you probably still have 2 times the Earth's gravity at the surface of the atmosphere.
Furthermore, also probably you would, if that wasn't a factor, you'd have to have the alignment of a particular object or galaxy, and because the gravity is so weak, the observer eye position to observe the phenomena as a focal point would possibly be outside of the solar system.
And again, that's the whole point, is looking at something outside the solar system. So I don't even know what that means. But the point is there will be objects. They don't all disappear. So there will be objects. and they all will be distorted. Anything in the lens won't be seen where it is. It's going to be seen somewhere else or not at all. That's what the lens does. There's no other choice. You can't say I can look through it when I want to and see reality, and then the next minute say it's distorting the image so I can see something I couldn't see. You can't have it both ways. If it does one thing, it does the other.
And then, because the phenomenon would be so small, amongst all the other diffuse photons flying around, you then have a necessity on exposure time and collecting the photons to see the image. Yeah?
Right, well that exposure time is going to be dependent on how far away the object is. So obviously you can't go with an object that's too far away, or Eddington couldn't have done his experiment, right? So I'm just saying, if Eddington could have done it, right, with objects around the sun, and he had to use objects that didn't move so much that they would just be a blur on the photo. So obviously he had to use objects that, you know, a 2 or 3 second time exposure was enough. Is there some other theory here?
It isn't a case of click, there, I got my image. When we're dealing with these objects that are travelling through tens of billions of light years, the photons are becoming very, very sparse, and you have to have a long exposure time to detect the statistical rise and fact that you're getting a focus.
Again, so irrelevant if Eddington did a correct experiment. So if you're going to make that argument, then I'm going to say Eddington's experiment was impossible, because he didn't have any device for compensating for the Earth's movement or any of that crap. So how the hell could he take a time exposure with a, you know, portable telescope and track objects in the sky for a time exposure? Obviously he didn't do that. So obviously it's not that difficult to find an object that a 2 or 3 second time exposure will satisfactorily resolve.
Of light from an object. So you can't just demand that various objects. You said it about the sun. Why is the sun not lensing all this other stuff? The kind of implication sometimes, the way you seem to think lensing should be in all these places.
Well, it has to be in the places inside where you're saying it is. So if you make a lens this big, I'm saying obviously there's more lens in here, a whole bunch more lens inside here. And inside there is all doing lensing too. So every object that went inside of that path has to be distorted or invisible. Has to be one of those two things. And it has to be more distorted than the object you're seeing. So whatever object you're seeing, however much angular diffraction there has been from its true position, inside the lens it's going to be even more screwed up. Even more angular displacement, or however you want to say that. So I'm just saying, you're not getting this point. So forget it. There's no point in making the point. I mean, the point is that this if lensing is true, it has implications, and nowhere has anybody accounted for those implications.
Night sky would just be a glow of lensed.
Exactly the point. It's exactly right. If these huge, giant, you know, light year across lenses exist out there, then we're not seeing anything right. It's all just distortive vision.
Light. Well, that's not the case, because you could imagine a universe, you know, a strategically placed universe where there was a galaxy. You know, maybe we were the center. We were literally the center of a universe, and there were all these galaxies placed, and they was all focusing on the Earth. And then you would, I mean, it was a question.
No, it's not the claim. So the claim is there's all kinds of galaxies out there, and some are going this way and this way and this way. So there's lenses going this way, and there's lenses going that way. There's lenses going this way, all kinds of angles. And all of those angles, all those lenses are, in some cases, not providing us a single bit of added value. It's just it's just takeaway. It's just denying us a vision. It's creating the cockeyed lens, which is just giving us nothing. There's no me anymore. It's just a bunch of nonsense. And that's the reality. If you're going to make a lens, you have to take the consequence of it. The consequence is when the lens is on edge, you're not going to see shit. You're going to see a mess. And especially at the inverse square law. It's a frickin' cube of a lens. Explain how it's not. Draw me a picture of the inverse square law converted into a lens.
It is a philosophical and scientific question. They say, well, if space is infinitely large and infinitely filled with these stars, why do we have a night sky? Is one of the questions.
Well, so this has nothing to do with what I'm talking about, right? So it's just completely off the subject. I don't care how thick the universe is. I don't care about any of that nonsense. That's not the point being made here. It's about lensing. And whether there's any practical way that you can gain all this visual value and you don't have to pay for it. So you can just get all the perfect little focused images and you don't get any of the distortion. That's not the way the universe works. It's not going to give you perfect lenses in all perfect locations. It's going to give you lenses in shitty locations that are going to make a mess.
And it's because, you know, that of the density that so many of these stars, that their light will never reach us because they're receding, they're outside of the visible universe. And inside the...
Right, we have to wait another 15 billion years or something before we can see them. Yes, yes. It's a possibility, but it doesn't really go with the theoretical stuff where they say the stuff on the edges of the universe ain't the same as the stuff here. So if the stuff out there 14 billion light years away is fundamentally different, then it's defining the universe as having a birth and now it's doing its death.
Visible universe, this isn't happening. All the galaxies are not arranged to make sure that.
I mean, I will point out again too that this whole argument that everything is spaced out. Well, we're seeing light from a universe that was really crowded. All right, much smaller universe than it is now. Everything was closer together. So the things we're looking at are supposed to be very close together, not very far apart. It's not as far apart.
They focus all their light on us. So we do see. I think there's other reasons, perhaps more technical reasons that I'm missing for why that we have a dark night sky. You know. So not only do we get the galaxy light from the galaxies, but from the furthest afield ones.
Yeah, well, obviously, without doing time exposures, the universe is pretty uninteresting. So if you do a time exposure, it gets lighter and lighter and lighter and lighter. So that's why it's dark, is because we are really, really terribly far away. And just like gravity, it gets really, really few photons way, way far away. So the further away you go, the less photons you get, just like the less gravity you get. But apparently that theory is in some dispute with you and Puro.
Suggestion that, that these galaxies be aligned exactly right, that we are a focal point observer for every faraway galaxy, is...
Yes, and it's exactly my opposite contention is being made. For every one where we're the focus, there's going to be 1,000 where we're not the focus and all we're getting is distortion. That's right. So for every time you get it just right, there's 1,000 places I can put this lens, 1,000 angles I can put it at, where all I'm going to get is fucking distortion. So for every one right, there should be 1,000 wrongs. So show me the evidence of the wrong lens. Because it has to be there somewhere. You can't get every single lens, can't be a goodie that creates a nice, clear little blob. They should be creating like insanely eccentric images. Taking up half the lens should be, white with the object.
It's a physical possibility, but it's a statistical, given the theory of how the universe was created, and the way the universe is it's never going to happen.
Well, whatever. Given the theory, I'm not terribly interested in all those gingerbread stories about the creation of the universe, frankly. It's a little hyper exploding and it's doing this and that. Yeah, I think that shit is just so undemonstrated or proven that why even listen? I mean, why give a shit? Until they have a science that can actually do any of that shit, what's the point?
Lensing is and always will be a rarer phenomena than straightforward collection of an image.
Well, again, I'll say it 4,000,000 times, I'll say it 7,000,000,000 times, I'll say, no, this is going to be the more common experience. You're looking, the lens isn't straight, you have your entire view annihilated of the accurate universe, and all you get is some kind of inaccurate gibberish that bends your way and happens to be in your focus. So you have no control anymore over what you see, because you can't see unfocused objects. They're all getting focused, and they're getting focused out of your vision. These every single thing that's going this way is gone. You're not going to see it from here. And yes, if you get in just the right position, you get to see one little thing over here. So you get to see the one little tiny thing when it's right, and you lose 1,000 things when it's wrong. Fact-ish.
By line of sight. So that's my answer.
Well, it's a shit answer. It doesn't say anything about the stuff disappearing and the stuff all in the wrong position when the lens is bent wrong, and how the stuff disappears because it's not going to be in your focus. The lens creates a focus problem. It's stealing your vision because it's focusing somewhere you're not. Again, it's just no different than this thing. I mean, at the right focus, okay, it works. At the wrong focus, fuck. Fuck.
I hope that's good enough. And I hope
No.
you describe what you think of what your position is on LIGO.
I've done my LIGO thing. Again, that's just so hilarious. I mean, I've only made at least a dozen videos on the subject. You know, my position has never been vague. I was against it before it even started. Okay, before they found their gravitational waves, I'm saying they're not going to find them, because Einstein's theory was kind of obvious in the sense he was talking about the movement of real gravity. He wasn't talking about making solar masses into gravity.
I mean, this is it's been inferred, or I've heard it spoken about, that this is the way modern cosmology is going, and probably in the future even particle physics will probably go this way with all open data. And
yeah, whatever, all open data. Again, you can say that kind of shit, and I don't see any of this open data bullshit. So it's not that open as far as I'm concerned. I don't see it. You can't even get a decent Hubble frickin' image. You know, I mean, oh, it's 2 megabytes. You know, that's the best they can do. And you don't get to see any of this stuff before they fiddled with it. You know, before they made the image. You know, you don't get to see any of the source data.
You can just inspect the data.
You know, and it's totally unindexed in any kind of rational way. I mean, go ahead and try to find a sequence of images taken, you know, 2 or 3 years apart of the same thing. It's damn near impossible to do.
The algorithms which are finding the information for yourselves. You know,
Oh, it's just such horseshit. It's a hell of a lot more complicated than that. You know, there's no putting the data online. I mean, it takes them months of work to run it through computers and shit. You just sit there and say, oh yeah, you just look at the data and you can see that it's all really great data. No, you can't see how many chirps are actually in the whole stream and why this particular chirp was selected as the chirp.
The only problem I see in science is...
he only sees one problem. No, it's got a lot of stupid assumptions and presumptions built into it, and it's flailing. It's so desperate. String theory, multiverses, Copenhagen. What the fuck? The only problem you see. You're not looking very hard.
Inadequate representation of philosophy of science to remind people that these...
No, there's no theoretical... Go ahead, show me on LIGO where they show you the theoretical sourcing for the conversion of matter into bent space, into non-material energy. You know, not energy of any normal kind. This bent space energy. Show me where that theory was tested or discussed or anything. Where did they do anything but just proclaim it as the new reality? Besides claiming that's what happens, where's the validation for it? Because it wasn't anything Einstein talked about.
The models, and if we think along these lines, then to help you put pictures to them.
I mean, Einstein would have speculated that if you could blow a sun up and turn it into photons, then the absence of the gravity would be noticeable. Gravity exists, then gravity disappears. That's a signal. So he'd say, yeah, you could sense that, but you're not going to do it from Earth. Yeah, we wouldn't say you're going to do it from here. I mean, if it happened to, like, Mars, if Mars just all of a sudden blew into photons, you could detect the absence of the gravity. The gravity influence would go away and there'd be a certain tug on the Earth because all of a sudden something that was influencing it is gone.
Model, you can think of it this way, but in a very real way, the model can never really be the actual territory, and we are philosophically, very really locked from ever understanding.
Yeah, well, it says you're locked because you have no imagination. That's your problem. I don't see any reason to be locked. If you just go by the simple logic that it's whatever the truth is, the mechanism is likely less complicated than this mechanism. If we can understand humans and we can do all the other stuff, dissect the human genome and all that shit, the mechanics of the universe, in my opinion, is going to be an easy task by comparison, in the sense that we know it's got to be something simple. Simple. It doesn't get more complicated as you go down. It's not whatever college graduate turtles all the way down.
For sure, the definiteness of how the microscopic works. And I think it's a legitimate criticism to say the nature of the models we pursue might be good predictively, but
I don't even think they're good predictively, frankly. I mean, all they had to do was get the idea of it. All they had to do was make the suggestion of it. Because if you actually try to use Einstein's equations, I've never seen anybody do a really successful job of it. I've never seen it done. And I certainly kind of demonstrated that with two-slit math. I mean, they always just say, well, look, here's what the equation comes down to, and this is what we factor it down, and we turn into this. But there's no numbers in the damn thing. And if they do come up with a number, they never compare it to an actual experiment. If it's anything, a significant prediction. I mean, of significant detail. I mean, obviously they can predict how much light might be hitting the surface. That one's too easy.
They're inherently never going to produce a mechanism model for how things work.
Now, again, says you. I mean, I don't see any obstacle to that whatsoever if your brain's screwed on right. And it's just the fact that they're not looking for mechanical model. They're looking for fields and multiverses and dark things with dark force powers. They're looking for fucking wizards and leprechauns. That's why they're not finding the truth. So they're not looking for it.
See, even if you have a mechanism model, there's always going to be an alternate mechanism model which fits the data. So
this is perfect, because this is an illustration of just how you just don't pay any attention at all, do you? I mean, okay, I'm saying.
That's for sure, because, for example, in Mendon's model of say, ejection of black particles at perpendicular angles, he could say that just as a rule. But I could say, no, there are little people down there, and they're sorting things.
Right. Now, that's not a simpler explanation, so that's the problem, right? So you can't do something extraordinary, like say I saw a UFO, and then just say that requires the same amount of evidence or the same reasoning as saying I have a glass of water. You can't do that with this extraordinary statement of where you're creating all kinds of complex mechanism. I'm not creating anything more complex than something moves this way and something moves this way, and when they hit each other, the thing going this way goes that way, and the thing going that way goes this way. Now, if you can tell me there's a simpler model for that reaction, okay, that doesn't require any kind of woo. I mean, it's as basic a thing. You can see it everywhere. You can see something very similar to it happening everywhere, every day. You can crash two cars into each other and see some portion of it happening. So fuck this bullshit.
And that's what they do.
I mean, the test is to have a theory. The simplest theory that explains the most is the winner. You get points off if your theory says, well, the force thingy does it. The virtual, the bent, yeah, you get points off for that.
And somebody else might have a circular interaction model that gives the same result. But
again, if they can make it simpler than two things colliding, if they can make a circular description of that that's simpler, go for it. Fine, I'm all for that. But they're not going to, because the rudimentary geometry is square, not round.
it's all hypothetical. It's all the character of those models are functional, as the word in Mendon likes to use. I think the correct word to stick by is properly explanatory.
Yeah, well, whatever. The words that should be used is sufficiently explicit, or detailed. There's just theories where, again, you just say dark matter did it. I mean, that's really not doing any work.
The models aren't really, they're explanatory in the context of the model, but they're not, as you understand, a real reality explanatory.
They're superficial, and again, and so they can match superficially circumstances. And that's all Einstein did, right? I mean, he got the right answer for the wrong reason. Yes, there's time dilation. Why is there time dilation? Well, it's not because of some bent space that's causing it. Okay, it's because of the simple argument that the stuff is moving further. There's more stuff happening, and his light clock is a perfect example of it, because it illustrates the more happening. There's more happening. So anytime there's bigger happening or more happening, the mechanism of the atom is going to be slower in accomplishing the task, because it's got to travel further. So I mean, but it's the wrong answer. Again, it's the velocity that creates that problem. It's not anything to do with bending space. It has merely to do with the fact that you're moving matter, and the matter is made up of little bits, and each little bit has to be moved. Each little bit has to be pushed. It doesn't just go on its own. Only the quanta are moving the speed of light. The matter can't just go the speed of light. All right, enough said.
So there's that.
Yeah, well, there's that. Not on the subject, I'd first say. So you didn't cover my objection, in my opinion, with much of anything. A little bit of vapor, but not even close. And the other subjects were just more reason to argue, because I don't think you have any of it right. Either about what's wrong with science, or regarding the actual bad science itself. So, I don't think I have anything else on the lensing thing. Like I said, there hasn't been a rational explanation for all the symptoms of the fact that there are lenses in space, big giant ones many thousands of times bigger than galaxies. If those lenses exist, the consequences of their existence is catastrophic to our view of the universe. No good to see with. Very bad.